Hello YouTube, my name is Daniel and welcome back to another video. In this video I will be doing an introduction to unit testing on Android. I will be using my Pokédex app, which some of you guys may have seen before. This is an MVVM Pokemon app using Room Database and Retrofit. If you guys would like to see the full series where I create this app from scratch, then I'll leave the link in the description. So to get started with unit testing, you'll need to make sure you have these dependencies if you want to follow along. Again, the code for this will be in the description, but you will need testing core dependency, JUnit, Hamcrest, architecture core testing, Kotlin coroutines testing, and the truth library. And later on for UI testing, you will need the fragment testing library and also the Espresso idling resource library, but that will be in another video. So firstly, to get started, we need to install the dependencies, and you will also need to create a package structure. So on the left side of my screen, you can see in the Android test directory, under source, we have an API folder, a database folder, and then a utils folder. And inside that, we have a test suites folder. The main test suite is where all of the classes are going to be placed, and these can be run at once. So we can have all of our tests being run at once so we can see if they complete or if they have any errors. The first aspect of the app we are going to test is the API. So it's going to be whether we can retrieve our Pokemon list from the API and also whether we can retrieve the Pokemon details. So to get started, we are going to create a test retrofit interface. So we're going to right click here, new Kotlin class/file, and this will be called and this will be an interface, and it will be called test API. The first function will be get Pokemon list. This will be annotated with the get annotation for retrofit, and the URL will be API/v2/Pokemon. The function will be a suspend function, and it will be called get Pokemon list, and this will return a retrofit response of Pokemon list item. If you don't already have this class, you will need to go ahead and create it in the models, but as I said, all of the related code will be in the description on my GitHub. And the other function will be to retrieve the Pokemon details. So this will be API/v2/Pokemon, and then we will pass in the ID. And we can do it like this with curly brackets. And this will again be a suspend function called get Pokemon detail, and it will have a parameter which will be a path parameter, which we can use the annotation path for, and we use the ID field. The parameter will be called ID, and it will be a string, and this will return a response of a Pokemon detail item. Now we've created our test interface, we need to actually create the test implementation of our API. And to get rid of this error, we can just remove this bracket here as it's no longer needed. So to create the test implementation, we will create a Kotlin object, and this will be called test API implementation. And this will have a single function called provide API, and this will return a test API which will equal retrofit builder. So retrofit.builder, we can pass in, we'll just run our import, We're going to pass in our base URL, which we get from our constants. Then we can add the converter factory, which is JSON converter factory. And what this will do is it will take our JSON response that we get from our API and turn it into our Kotlin data classes, such as the Pokemon list item or the Pokemon detail item. Then we need to call .create on the converter factory, call .build, and finally .create. And then we pass in the class, which is test API class.java. And now we can actually start writing our tests. So on the API package, we want to right click and select new Kotlin class/file. And we will call this class API isolation tests, as we will be isolating the API and testing it independently. Now we want to annotate this class with @run with Android JUnit class runner. So Android JUnit 4 class runner and class. There we go. And this class will also have to implement the test case class as it will be running tests. Now all functions in Android testing will need to be annotated with @test, and that is the JUnit annotation. The first one will be called test Pokemon API detail result success. So we are just testing here whether we can call the API and we get a successful response. This doesn't mean we actually get data, but it just means that the API returns a 200 OK response. So we are going to initialize our API here. Just add a bit more space to this class. So to initialize the API, we're going to call test API implementation.provide API. Then we will have a test, and that is going to equal run blocking, as we need to run a coroutine. And it's okay to block the thread on the test, as to not actually run the app. We'll call the API, get Pokemon detail, and pass in ID. We'll just use ID1. And then we are going to use the assert function, which is assert equals. Our expected result is test is successful, and we want it to be true. And that is what we are passing here. So we are expecting to call the API and it to return a successful response, and just making sure that works correctly. Now we can add the API isolation test class into our main test suite in order to run it. Just like this, just add it in the suite. So main test suite class, there we go. And now we can actually run our main test suite and see if it works. So I'm going to click here, run main test suite. Okay, so I see I made a small error here. Instead of putting the API isolation tests, I actually put the main test suite in here. So of course that is not going to work. Let's run this again and see what we get. So building, installing, and it's running. Shouldn't take too long. And we can see the test has passed, and we've got a successful message saying that it was able to get a successful response from the API, and that means our tests are running correctly. So now we can get started writing the rest of the tests for the API. So going back to our main API isolation tests, we want to copy and paste this function, as we will be creating a similar function for testing the API list. So we're going to copy and paste, change detail to list, and then change the function to get Pokemon list, no parameter, and this will remain the same, just make sure it's successful. Then next we are going to test whether this response was able to retrieve any data and whether it was not empty. So this will make sure that the API is in fact working, but also returning the data that we require. And we will call this method result not empty. this will call the same function, but we are going to assert that test.body.results, because that contains a list of Pokemon, is not empty. And we're going to test that is true. And now, as the Pokemon detail API request doesn't actually return a list, it returns a JSON body. We are just going to check that that is not null. So I'm going to copy the first function here, which checks whether the detail request was successful. I'm going to change it to check that it's successful and not null. So it's going to be called not null. It's going to call the same function, passing the same parameter, and it's just going to check that test.body is not null. And that is all the tests we are going to have for the API. As I said, this is just an introduction, so we're going to test all these, then move on to the Room database tests. So let's run the test and see what we get. So going back to our main test suite, I'm going to click on the play icon and select Run Main Test Suite. And it should run our 2 new tests, and let's see if these work. Just wait for the Gradle build, install, launch succeeded. It's running tests, and we can see they all worked successfully, and we can see the speed that this is happening. So it's able to test the API, and it finished in less than, well, a couple of seconds really to test our whole API and making sure that this is correct. It's much quicker than running the whole app in your emulator also, so it's a really good idea to get started writing some unit tests. So now these are working, I'm going to get onto the Room database. So in our database package, we're just going to have one class called Room Database Test. And this will again implement the test case class. And will need to be annotated with run with Android JUnit4 class. And we need to create 2 latenit variables at the top for the Room database and the Room DAO object, and that will be private latenit var Room database, and this will equal Pokemon database, which is a class I created in the main app. Next, we will have one for the DAO, which we will call Room DAO, and that will equal Pokemon DAO. Now, before we actually run the class, we need to add a setup function so that our Room database is set up before we actually start our tests. In order to do that, we have the annotation called @before from JUnit, and then we want to call public override fun setup. And in here, we'll actually set up our DB. We first need to initialize the context, which is application provider.getApplicationContext, passing the type context, and this will get our application context from our Pokemon app. Then we can initialize our Room database, which is room.inMemory database builder. So this will be built as we are running our tests. Context, and passing the class Pokemon database class.java, and then call .build, and that will build our DB. Next, we can initialize our Room DAO, which will be Room database.Pokemon DAO, and then afterwards, we want to tear down our DB instance, so we use the @after annotation, and the function will be called closeDB, and this will just run Room database.close, and that will close off our DB after our tests have run. Now the first actual test will be to insert an item into our Room database and see if we can retrieve it. So this will be called insert room item. we will initialize the room item, and it will just be a custom Pokemon item. So that will be custom Pokemon list item. The API ID for this will be 1, the name will be blank string, and the type will also be blank string. And now we want to insert that into our room DAO. So room DAO, call insert Pokemon, which is a method I created in the main app. Insert the room item. Now we want to retrieve that item, so we'll call this retrieve, and that will equal room DAO dot get Pokemon. And then we want to check whether this list is not empty. As this is being built in memory, it will be an empty DB. We just want to make sure that we can insert this Pokemon into the DB and that it's been retrieved. So retrieve is not empty, and that should be true. Now we can just run this test here by clicking on the room database test, and we'll just run it and see if this works. Wait for that to be built and installed. And we can see that worked successfully, and it's really quick as well. So next is a similar test, and we are just going to insert a detail item into our database. So insert room detail item. Our item will be a Pokemon detail item. Put this on a new line. Now there's quite a few things which we need to initialize by default. So the abilities will just be an empty list. Then we'll have the ID, which will be 1. Then the name, which will be an empty string. Then the stat object, which will be again an empty list. The types, which is an empty list again. And then finally we have the sprites, which is the Pokemon images. And we just pass an empty string for the front default, and then the other sprites. And then we just need an official artwork class, and then pass in an empty string. And that'll be enough to create our detail item. Then we just need to call insert Pokemon details item. And for the method, it will be get Pokemon details with the ID of 1. And then we are just going to make sure that it's not null. So room item retrieve is not null. Okay, and as this is a suspend function, it just means we're going to have to run this in a coroutine scope. In order to do that, we can use run blocking. So we just call on the function body, run blocking, and that will resolve that issue. And that is how we can test inserting a details item. Now, the next test we are going to do is preceding the database. So in this app, when it first runs, I run a work manager class to precede the DB, so we actually have some Pokemon in the database for the user to actually see before they actually start making requests to the API. So to get started on that, we're going to create a function called precede test, and that'll be test fun precede test. And this again, we'll be using run blocking. We'll first initialize the list, which I get from the constants in my app, which is a giant list of Pokemon. Then we can call a function from my DB, which is insert Pokemon list, pass in the list. And then we are going to check whether the first item in that list is equal to the first item in the DB. So we are first going to retrieve the list from the DB. So retrieve equals room DAO dot get Pokemon, and that's going to retrieve all of the Pokemon in our DB. And then we are going to assert that the retrieved list, the first item in that list, has the same API ID as the list that we inserted. So list.first.API ID, and we expect that to be true. And that is all we need for that test. And now we are going to test searching the DB, which is done in the main screen. And that will be called fun search name test. And this again will be using run blocking. We initialize the list. So list equals constants.precedDB. We can then insert list. And now we are going to initialize a search. Just use the insert Pokemon list function. Initialize a search, which will be room do.search Pokemon by name. And we'll put in a name called Butterfree, which is the name of Pokemon in that list. And then we can call assert equals search. And we are going to check whether any Pokemon in that list has the name Butterfree. And this is a cool Kotlin extension function where you can just search for any detail in that list, and if one of them has that detail, it will return true, and if not, it will return false. So if any Pokemon in that list have the name Butterfree, it will return true. And then let's make that not nullable. Passing true. And that's all we need. The next test will be testing whether we can search for a Pokemon by type. And this is done using a filter icon. And this will be called search type test. We're going to do the same thing here. Insert the Pokemon list. In the search, we are going to call room do search Pokemon by type. And our type will be bug. And then we have the same here, except it's going to be it.type equals bug. And that is all we need to test whether we can actually search the Pokemon list by a type. And then the final test is we are going to test whether the last stored object in our DB is the same as the last Pokemon in our list that we insert. So it's just making sure that we have accurate data in our DB and the DB isn't making any weird modifications to critical details such as the API ID. So this is one of the methods you can have there, and just have it in there whenever you're making changes to your app, just to make sure that you have correct results. So last stored object test, we will initialize the DB with a list like that. We will then get the instance of the last item in that list by calling list.last. We then will insert list. Then we will retrieve the Pokemon. So that will be room do.getPokemon. And we are then going to assert that the last Pokemon is equal to the last Pokemon in the DB. So we will call this Pokemon.last.API-ID is equal to the last Pokemon in that list, API-ID, and then true. And that is all we are going to have for testing our room database. So we are testing whether we can insert each of the Pokemon list item and detail item, and also search them and retrieve them. So now we can actually go ahead and add this to our main test suite, just underneath the API isolation tests. So if you add in here, room database test, class, and then we're going to hit play and run all of our tests together and see if they perform successfully. So see here, we're just waiting for the build and the install, and we can see how quick this is. So this is going to test all of our API and also all of our DB as well. Right, we can see all of the tests run successfully, so that's absolutely brilliant. And in total, it took less than a second to run all of those tests, so that is absolutely brilliant. We can see within a second that our room database and our API is working correctly. Now I'm just going to add a few more utility test methods to this app so we can test some of the implementation, and that will be it for this video. So the next class I'm going to create will be in the utility package, and it will be called utility method tests. And this is just where I'm going to test some odd methods that I have around the app, just to show you guys a few more types of tests that we can do. This will again implement from test case. So the first thing I'm going to test is in our map fragment, I want to test how random the position is of the Pokemon that are going to be placed on the map. So we can see here, I've got a map here on this page, and the Pokemon sprites are going to be placed randomly throughout this map, and I want to see how random that position is. So first off, I'm going to create a test, and that test will be called random positioning test. So positioning test, and it will start with a lowercase r. And first off, we're going to create a list of integers, and this will be the positions that it will create. So random ints, and that will be a mutable list of ints. Now we're going to create a loop which is going to run 20 times. So that will be I in 0 to 20. And each loop we're going to add a random integer to that list. So we will add, and we will call 0 to 600. So a random integer between 0 and 600. And we're going to add that to the list. And we want to make sure that this list has no duplicates. So every single integer in this list will be completely random and there will be no duplicates at all. And we will call assert equals random ints dot size equals random ints dot toSet dot size. And how this works is it changes this mutable list into a set, and this set does not allow duplicates, so it'll remove any duplicates from the list. But if we can see it's the same size as the list when it originally started, we know there was no duplicates and they were all random. So that is the first test. The next test, we want to make sure that this method here, which should take a random integer between 0 to 600, actually takes a random integer, and it doesn't have any integers outside of that range. So I'm going to go ahead and copy this, and we will call this random range test. We'll still have our list of random integers. We're going to increase this loop, so it'll be for 0 to 200, so this is going to loop 200 times. Same method here, and in the assert, we are going to remove this condition, and we are going to check, so random ints dot filter. We want to check where 0 to 600 contains it. So that will make sure that every single integer in this list of 200 ints is in fact within this range, and that should be true. And the final test I'm going to show you guys is testing our type converters for Room. So in our main package, I'll just show you some of the type converters that we use. So in my Pokemon detail item, I have a class called converters, and we can see what we're doing here is we're converting a Kotlin data class of Pokemon ability to a string, and then also retrieving it from a string as well. So we just want to test whether that actually works correctly. And we could do it for all the classes, but I'm just going to do it for one, just to show you guys. So back in the utility methods test class, we're going to write our final test, which will be type converter test. We will first initialize our Pokemon stat item. So this will be a list of Pokemon stat. And the base stat for this will be 6. Effort will be 6. Then we'll have our stat object, which will be a name and URL. And and both the name and the URL will be called test. Now what we want to do is we want to take this list of Pokemon stat here and convert it into a string, and then just make sure they're actually equals the same when we retrieve it as well. So first we are going to retrieve our string by converting this list here. To do that, we will call list, and then we will initialize our converters class, and we will call from Pokemon stat and pass in our data. So we have our list now, and we want to run assert equals. So we're going to take that string we just created and call converters dot to Pokemon stat, and this is going to take that string and it should return the Pokemon stat item, and we're just going to make sure that that is true. And to improve this a bit better, we probably shouldn't be instantiating that class twice. So I'm going to initialize it up here. We'll just call this converters, just like that. Then we can call converters.from Pokemon stat and converters.to Pokemon stat, and that will be it for our tests. We can go back to our main test suite and add the utility methods test to the main test suite. And now let's run all of our tests at once and see if they are successful. Right, so I'm going to click here, run main test suite. Okay, we can see the API and the database tests run successfully, but we've got a warning in the utility methods test. So let's see what that is here. And it's because we have not added the annotation at the top. So always make sure you have your annotations here, and that will be run with Android JUnit 4 class. And let's rerun the tests and see whether that is working now. Let's wait for it to build, install. Okay, we can see we've got an issue here. So the random range test has failed. That's because we didn't actually check the size of the list. So what we're going to do is we're going to check whether the filter.size equals random int.size. So what should happen is it should filter the random ints all the way down and make sure that every single one of these is within this range, and then we're going to check the size of that list and make sure it's the size of the initial list before the filter. So this means that every single int was in that range. So let's run that test and see what we get. And we're just going to run this again to make sure we have a full list of all past tests. And we can see that all of our tests have completed successfully and they're all working well. In the next video, I'll be showing you guys how we can do some UI testing with Espresso, which is the main Android library for doing UI testing. If you guys haven't checked out the full course where I make this Pokemon app from scratch, the link from that will be in the description, along with the code for these actual unit tests as well. Please like the video and please subscribe.